All right, let's go ahead and get into section 1.3 notes. Today we're going to explore and look at midpoint and distance formulas. Now, you might have seen the midpoint and distance formula back in algebra. We're going to be doing midpoint and distance in respect to a coordinate plane. All right, we're going to be dealing with ordered pairs, so it's going to be formula driven. So let's start off with the midpoint formula. M for midpoint equals, okay, our answer is going to be written as an ordered pair here. So we're going to take x plus x and then divide by 2. Now it's important that we add those numbers first and then divide our final number by 2 at the end. And then we're going to take our y plus our y and divide it by 2, and that's how we get our ordered pair. Now remember, our ordered pair, when we look at two numbers inside the parentheses, our first number is our x, our second number is our y. All right, so let's go explore example number 1. It says find the coordinates of the midpoint. So find the midpoint, so we're going to plug it into the formula. All right, now remember, the x is the first number inside the ordered pair. So our first x is a -8, our second x is a 2. So let's plug it into our formula. All right, here we go. I'm going to do x plus x. So I see a -8 plus, and then a +2, and divide by 2. So I set it up first. Now I'm going to go back to my y's. My first y is a 6. It's not underlined. Plus a -1. So I've plugged it in exactly how I see it. All right, now we're going to go ahead and clean this up a little bit. All right, I know that -8 plus 2 gives me -6, and then I'm going to divide by 2. And then I know 6 plus -1 is a +5, and then I'm going to divide by 2. So we will clean up our answer one more time. -6 divided by 2, we know that that equals -3, so we need to reduce and clean that. If we can reduce a fraction, we will. 5/2 we cannot reduce, so we may write it as a fraction. If you don't want to write it as a fraction, you may also write your answer as a decimal. So these two answers in purple are the same. Either one of them would be correct and accepted. All right, that's going to put you on for you guys to try. We're going to have you plug this in, and then we'll compare answers when we're on our Zoom, and we'll talk and see how you did. Let's go ahead and move down to the next example, and let's talk about what happens if they ask the question slightly different. All right, so you'll notice, what if we were given one endpoint and the midpoint? Can we find the other endpoint? All right, so it's very important that you realize what the question is asking. For example, example 2 says M is the midpoint. So they're telling us what the midpoint is. They're already giving us that answer. You'll notice if you scroll back up to example 1, it said find the coordinates of the midpoint. So find the midpoint. If it asks us to find the midpoint, we're going to plug it into the formula. However, this one says M is the midpoint, and it wants us to find the coordinates of B. All right, so we're going to draw this to think about this. Now, midpoint means in the middle, right? We're trying to find the middle of the segment. So if we look at this from a visual standpoint, here's what we're looking at. We've got a segment. Remember, a segment ends, 2 endpoints. The midpoint would be in the middle of it, okay? It says that M is the midpoint of AB. A has coordinates 2, 5, so we're going to throw the coordinates, the endpoint coordinates, at the end on the left first. Okay, now you'll notice that it also gives us the midpoint. M, the midpoint, M, has coordinates 5, 1, so because that's the midpoint, I need to put that in the middle, 5, 1. What they're trying to do is they're trying to figure out what is the other endpoint. So what is our missing coordinates at the end? All right, so here's where we're going to look at the jump. We always start at the endpoint, so I'm going to start on the left end. I'm going to compare my x's. So if I start at this 2 and I traveled up to 5, okay, we went up, so we traveled positive. So I went up, positive. From 2 to 5, we went 3 to get there. The gap is 3. I'm going to stay at this 5 from the middle, and I'm going to add the jump, which was 3. So 5 plus 3 tells us 8. All right, now we're going to do the same thing for the y's. I'm going to start at the end. I started at a 5, and I traveled to the middle, which went down to 1. Okay, notice 5 went down to 1, so we went down. So this time we traveled negative, and the gap from 5 down to 1 is we went down 4 to get there. So now I'm going to start at this 1 in the middle, and I'm going to go 1 minus 4, which tells us negative 3. So our answer is 8, negative 3. Now we can check this. If I add the two endpoints and divide by 2, I should land back at the midpoint. All right, so again, the key here is you've got to see the difference between the question. Example 1 said find the midpoint. Example 2 says M is the midpoint. All right, we're going to give you this one to try, and then we can compare it when we see you on the Zoom, and we'll discuss it in class and see how you did. Okay, that brings us to our second formula of the day. Second formula is the distance formula. All right, the distance formula will tell us or be the following. Now remember, distance is the same as length. So if it says find the length, we can plug it into the distance formula, same type of deal. All right, x minus x squared plus y minus y squared. Okay, there's our formula. Now, the key to this formula is to take your time, plug things in first. Don't try to clean everything up right away. Now, you have to be very careful with signs when you do these. Remember, negative will change to positive, things like that. So we got to make sure we just take our time. Now, it's important also to state whatever x you start with, you must start with that y. Okay? Here we go. Let's try one. We have our formula, distance formula. We know x is the first term in the ordered pair and y is the second. So we are going to begin to plug this in. All right, my first x is a negative 3, so I'm going to start there. Negative 3 minus. My second x is a 4, and I'm going to square that. Plus, now here's where you got to make sure, because I started with the negative 3 first, I must start with the negative 5 in the second one first. I'm going to copy the sign from the formula. It's a minus, and now look, we have a negative 6, so I'm going to put negative 6. So you'll notice we go very slowly, take our time, get the numbers in correctly first into the formula, and then we'll go through and start to clean this up. Okay, let's change colors real quick. Here we go. Clean it up. We want to clean up each piece and don't square root it until the very end, and we're done. Negative 3 minus 4 is negative 7, and we're going to square it. Plus, negative 5 minus a minus, ooh, that's going to change to a positive because we have two negatives there. So negative 5 plus 6 will give us a positive 1, and we're squared. Okay, so we have it into the formula. Again, I'm not rushing through it. I'm just cleaning things up so that I know I get the correct answer at the end. Now, here's where you got to be careful. Remember back to your algebra days, negative 7 squared, we know that anytime we square a number, it has to turn positive. So negative 7 squared, remember that's negative 7 times negative 7, which changes to a positive 49. If you're going to put that into a calculator, you must make sure you use parentheses, otherwise some calculators will lie to you. All right, so if you're going to square something and it's a negative number, make sure you use parentheses, because if you don't, your calculator might say negative 49 because it reads it a different way. You're smarter than the calculator anyway, so it's all good. All right, 1 squared is 1. 1 times 1. All right, here's where we just clean this up now. All right, so 49 plus 1 is going to give us 50. But notice I have a square root above this, so I must keep that square root in my answer. So square root of 50. Now, that's not a perfect square, so I can leave my answer like this if I'd like to. If it's a perfect square, then we got to write the actual number it changes to. Now, if it asked us to round this, or if it asked us to go nearest tenth, then we would plug in the square root of 50 right into our calculator, which is up to you. We will accept either answer typically. So if you plug it into your calculator, it tells you 7.07, and if I'm going nearest tenth, I'm going to write that as 7.1. So square root of 50 or 7.1, those are the same answer. All right, again, just make sure you take your time plugging it in to the formula so that you can get it cleaned up and get to the right answer. We're going to leave you letter B to try, see if you can do it. I know you guys can. All right, and then we're going to look at example 4. Example 4. Okay. Example 4 says find the distance. So we're still continuing to do distance, so it's very similar to what we just did up above. The problem with this one is that they don't give us the ordered pairs, so we've got to find them. So we need to figure out what is this point right here. So remember, we're going to start at 0, 0 in the middle. I'm going to go right 5 first. So 5 will be our first coordinate. And then I go up 1. So our first coordinate is 5, 1. Our second coordinate down here, notice if I start at 0, 0, I don't have to move left or right, so my first move is 0. But then I got to go down 5. Down 5 would be -5, so this ordered pair is 0, -5. Okay, this gets us ready to start the distance formula now that we're ready. So we have our x's and our y's. Let's go ahead and draw our square root symbol, and then let's begin to plug things in. I'm going to start with this x, the 5. So 5 minus my second x is a 0, so 5 minus 0 squared plus, now I'm going to go to my y's. I started with that 5, so I'm going to start with the 1 minus a -5 squared. All right, we begin to clean this up. Now remember, we said don't rush through this, so here we go. 5 minus 0 is 5 squared plus 1 minus a -5. Ooh, minus will change to a plus, so 1 plus 5 changes to a 6, and I'm squared. All right, I'm going to continue to clean this up and get it all set. Final answer. 5 squared is 25, plus 6 squared is 36. Now I'm going to add the two numbers underneath the square root together. When I do that, I get square root of 61. Okay, that is not a perfect square, so I may leave my answer like that. However, if I wanted to go ahead and write it to the nearest tenth, if you put that into your calculator, you'll get 7.8102. So if I go nearest tenth, I'm going to call it 7.8. All right. Example 5, we're going to have you try in a second. I'm going to do part of 6 with you because I need the room to write down, or the part of the last problem with you, because then we need the space to write with my handwriting. All right, this symbol right here in the middle stands for congruent. Congruent. All right, congruent basically means are they the same length, same distance? All right, so what I'm going to do is I'm going to start down here, and I am going to find AB for you. All right, you're going to be in charge of finding CD and seeing if it's congruent. So you're going to see if CD matches. Now, we are not allowed to just look at these pictures and say, hey, they look like they're the same. All right, we can't count it. We need to prove it. We need to do the distance formula to show it, like social distance formula. All right, here we go. I'm going to do AB. Okay, so we're going to do AB right here. I'm going to write the coordinates for A and B. So A, if I start at 0, 0, I have to go over 1, 2, 3. So I went -3 first, and then I went up 2. So there's my coordinates for A. If I'm going to do B, I started 0, 0 in the middle. I don't have to move left or right, so that's a 0. And then I'm going to go up 3, 0, 3. All right, we've got our coordinates, so let's begin to put these in. Here we go, our distance formula. Square root symbol. All right, I'm going to start with the first x that I see. I see a -3, so I'm going -3 minus 0 squared plus. I started with the negative 3, so I'm going to start with the 2 minus the other y, which is 3 squared. All right, let's start to clean this up. Let's go to a new color. Negative 3 minus 0 is negative 3 squared, plus 2 minus 3 is negative 1 squared. All right, I know you remember what we said earlier about what happens when we square those negatives. Negative 3 squared is going to change to a good positive 9. It didn't trick you. Negative 3 times negative 3. Plus negative 1 squared is going to change to a positive 1. Very good again. Here we go. 9 plus 1, without a calculator, gives us square root of 10. Square root of 10, we may leave our answer like that. All right. However, if you're one of those that says, hey, I don't like the square root symbol, I want to write it as a decimal, well, I get 3.16 when I put it on a calculator, so 3.16 would round to 3.2. So you may write your answer either way. All right, so what you're going to do is you're going to find the distance of CD. If your answer ends up to be the square root of 10 or 3.2, then yes, they are congruent. They're the same length. If, let's say you get some other number underneath the square root sign besides 10, so let's say square root of 20. Those are not the same, so then you would say no, they are not congruent. All right, but we're using the distance formula to prove that they are the same length, same distance to make them congruent. Okay, you are also going to try this example, example 5. It's the same as what we just did below. You might be able to write and fit it a little bit nicer than I can, but overall, very good job with the distance and the midpoint. All right, notice the difference between the questions. Use those formulas, be able to use the formulas, and we will go over the other ones in class and help you with anything you need. Great work today. Keep up the excellent work.